What's up, Algebra 2ers? Here's your PA.4 on IL Classroom video key. So the first slide was just a what do you notice, what do you wonder? So some things we talk about in class is here's your graph of f, but g compared to it is a reflection of f over the x-axis, which means any point that was here is now on the other side of the x-axis, which is this point here, corresponds to that point. And h compared to f is a reflection over the y-axis. So any point over here, like it's 1, 2, 3 away, that point is now 1, 2, 3 away over here. And so that's what happens with reflections. If you get it says here is a graph of f of x, a different function g is defined by g of x equals negative f of x. Putting a negative in front of a function is what causes the graph to flip over the x-axis, because remember f of x means y values, and so putting a negative in front just changes all your y values from positives to negatives or negatives to positives. It makes them opposite. And so if f of negative 1, that just means find the y value when x is negative 1. It's right here. And so then g of negative 1 is the same y value, but opposite. So g of negative 1 is 4. And so here's the point on the graph of f, which I highlighted in orange right there. And so g of negative 1, the same x value, has the opposite y value of that. And that is how putting a negative in front right here affects a function. Okay, so here is a graph of function f in a table of values. And then we had to let g be the same thing as above. G is equal to negative f of x and complete the table. So remember, f of x is just y values. So these y values on the graph of f are all those. And then the y values on the graph of g are the same as the y values on f, except opposite. So if that's negative, we make it positive. 0 just stays 0. And a positive number becomes negative. And then I sketched the graph of g in purple up here. And you can also see when it reflects over the x-axis, like anywhere this graph is decreasing, its reflection is going to be increasing. And then describe how to transform the graph of f into the graph of g. Explain how the equation produces this transformation. G is a reflection of f over the x-axis. And then explain how the equation produces this transformation is because all the y values become opposites. And that's what causes it to reflect over the x-axis. All y values become opposite. Okay. And so describe how to transform the graph of f to get the graph of these different things. So if there's a negative in front, that's when it gets reflected over the x-axis. A plus 2 right here, this is from the previous problem set, is the graph of f is shifted up 2. This makes the graph go left 4. And this one just puts it all together. Just make sure you do the plus 2 last, because the order does matter. Reflecting something and then shifting it is different than shifting then reflecting over the x-axis. Like, since these both have vertical changes, you have to make sure you do this one last. And so this is a shift left 4 because of this. Then it's reflected over the x-axis. And you could switch the order of these two, that doesn't matter. But the last one you have to say is f has been shifted up 2 from that. And then we were to sketch a graph of this given function f in a different color and label the graph with the name of the function, which is g of x. So there you go with that. And then all I did was take the points that I see. This is at negative 0.8, so I made it positive 0.8. That's at positive 2, so I made it negative 2. This is at 1.6, so I made it negative 1.6. Where this is going down, the reflection is going up. Where this is going up, the reflection is going down, and so on. And that's it for your reflections.